in just a second. Desmond show you the best way to see the effect of A, B, and C that has on the graph of y equals the sine of x. That A affects the amplitude of the original function. That is how high it climbs and how far down below the x-axis it goes. B determines the period. The period of this function right here, sine and cosine, is 2 pi. If I stick a B in there, it changes the period by 2 pi divided by B. And the C, if we rewrite the function this way, factoring out the B, it's easier to see. This C over B is what we call the phase shift, and that shifts the original graph either left or right, depending on whether C is positive or negative. So let's see what happens over here. So here's the graph of y equals the sine of x because A equals 1, B equals 1, and C equals 0. So we start at 0, 0. At pi over 2, we climb to 1. At pi, the sine is back to 0. At 3 pi over 2, negative 1. And at 2 pi, we're back to 0. That's one period of the sine function. And after that, it repeats every 2 pi radians. Now watch what happens when we change A. Oh, and by the way, these two graphs show that these are equivalent. So I'll leave this with the black version. So as A increases, the amplitude increases. If we get less than 1, it just doesn't climb all the way. It doesn't climb all the way up to 1. And if we go less than 0, it reflects the graph over the x-axis. So instead of climbing to 1, well, I can change this to a negative. It falls to negative 1 starting out. There we go. But we still have the same period, 2 pi. Let me go back to 1 here. And let's change B. And B is a phase shift. I'm sorry, a change in the period. If I increase B to 2, the new period will be 2 pi over 2 or pi. So watch what happens. I change B to 2. Notice that now this sine function repeats within just pi radians. So whatever B is, take 2 pi and divide by B, and you'll have the new period. If we have a value that's less than 1, like 1/4 or 1/2, let's say, pi over, there's 1/2. I can't get it to 1/2. Come on. Well, we'll do it this way. There we go. Okay, so 2 pi divided by 1/2 is 4 pi, so it's all the way out to 4 pi before the sine function starts another period. So B affects the period. Let's reset this to 1 and then talk about phase shift. So if I increase C to the number 1, the phase shift will be C divided by B, which would just be a 1, and we'll have a phase shift to the left because C is positive. So see the graph shifting? And instead of going through the point 2 pi, we shifted to the left, it goes through 2 pi minus 1. And if I have C equal 4, the phase shift is 4 to the left. So it'll go through that point now. 4 to the left. Okay, and you can do any combination of these. So I can start increasing amplitude, changing period, and changing the phase shift. And we can even shift in a positive direction by having C be negative. Okay, so I hope that gives you some idea of what A, B, and C values do to the graph of the original sine function. And by the way, I could graph y equals the sine of x so you can compare. We leave that stationary. You can see that, or make the comparison. And if I just leave this at 1, 1, and 0, I match up with the original graph. So there you go. Hope that helped. If you have any questions, post a comment.